Okay, so let's jump on. I haven't got out of that yet. 645065. 645. 65. Interwaiting room. Come on, should go there. Go there. What happened? Interwaiting room. 645065. 64065. Seven six oh 552. Why aren't you working? Swear this works so well, and then now I have to share my room, and what doesn't work? Is in here, just let's copy on it. 760-552, 760-552. Enter waiting room. All right. All right. So you have your homework coming up. Give me a sec. I need to just reset this. So what gave you some trouble on that homework? Was the new synthetic division I showed you for like one example, like in one ear out the other? Because that makes you normal if that's the case, and that's okay. Let's catch you up on that. Well, poop. Come on. Well, that's where you want to be. I gotta go old school. You see this board okay? Okay. Not if I'm standing right here though. And it is K. It's K. 748. Okay. Starting Beadster. Six five two 65259 641. Connect. Maybe this will work. Try not to get anything. I didn't get you. Let's see. It claims it's trying to connect. Oh, I see how you are. Three, two, 7, 1, 1, 5, 8, 5. Let's see if that is gonna work. Come on. Come on. All right, there we go. All right, so what kind of questions did you come across on the homework, or am I just on the whole second page? And that was for the review number 1, yes? 19? Yeah, let's take a look at it. 19. So we want to use synthetic division on this particular problem. Now, it might not seem like it, but you guys are actually at a true advantage because of technology these days, because Desmos will work for you. So let me ask you this. It's raised to the third power. So how many solutions should there be? 3, right? Now, there's a mathematician, his name's Descartes, or it looks like Descartes. He came up with a rule of signs, and he figured out a way to, without calculators or anything back in the olden days, to determine where you would have solutions to this problem. And if it's raised to the third power, you have 3 or 1 places that it would cross or touch the x-axis. Okay, so this could technically be a wiggle on as it crosses the x-axis, which means it's crossing there 3 times. This, if it crosses through directly, it could, it means you have exactly 1 solution. If you have a bounce, you have 2 solutions. The fortunate thing about when you were doing this math back in the old day, because of Descartes, you were able to determine a whole lot of things basically by taking all of the factors of the very last number divided by all of the factors of the leading coefficient, in this case, which would be 2. Nice thing is, we're not doing that. We're going to go right to our best buddy and pal, Desmos. All right, so 19, we're just going to go y equals 2x raised to the third, and then plus 5x squared plus x minus 2. All right, so now this truly has found us all 3 of the solutions. So theoretically, our problem, without even using synthetic division, because it crosses at very good points on the x-axis, we could say the -2 leads to the binomial of x plus 2. The -1 leads to the binomial x plus 1. And the 0.5 is the same thing as 1/2, which means it would cross the x-axis at 2x minus 1 if you reverse that. But let's do the synthetic division like it asked. Let's deal with the point, or the -2. So I'm going to take that -2, and I'm going to synthetically divide. I'm going to take all the lead coefficients. There's a 1 there. So I have 2, 5, 1, and -2. The lead number comes straight down. You get a 2. And then you multiply the down number times the outside number. So that's going to give me -4. Add those together. That gives me 1. 1 times -2 is -2. Add those together. That's giving me -1. -1 times -2 is +2. If you add those together, you get 0. because you get a 0 on that very outside, very last term, that means it truly does verify that it does cross the x-axis. In fact, this means that you have -2 comma 0 as a point on the graph, which we could see. Now, the nice thing about doing this is if you found that first one, you can find a second one. I think -1 was another location, and you don't have to synthetically divide by -1. You could just take whatever you had left here because it worked out to a 0, and you drop the first number down. 2 times -2, or excuse me, 2 times -1 is -2. Combine those together. That's going to give me -1. 1 times -1 is going to be +1. You add those, you get a 0. So that, again, verifies that this is a point on that graph. And the nice thing is, if you were going through this, this whole thing was x to the third. This could be x to the second plus 1x plus that. So that could be that part. So that means as it's decreasing, this right here is the same thing as 2x minus 1, and that's equal to 0. Solve it algebraically, add 1, divide by 2, and you're going to get the 1/2. Now, the nice thing about this whole process and thought process that goes with it, 1/2 isn't always, when we deal with fractions, yes, we could use a fraction on the synthetic division. We could use a decimal. Where you can't use it is if that fraction or if that decimal was a decimal that was irrational, meaning you could not write it as a fraction. But so if I were to truly factor this whole problem down, this gives me x plus 2. So that's one answer. This gives me x plus 1. That's another answer. And then we have the 2x minus 1. So my answer factored out is x plus 2, x plus 1, and 2x minus 1. That is the factored version. If you were to break that all the way down into what binomials or monomials could be multiplied together to give me that, if I were to FOIL together x plus 2 and x plus 1, and then I were to double distribute whatever that answer is with 2x minus 1, you would indeed get 2x to the third plus 5x plus x minus 2. Bless you. Any other questions you might have come across on this assignment? Yeah. 18. Okay. Same idea that we're going to go through. 18's right there. Okay, so number 18, we're going to do the same thing. We're going to start out using Desmos. Okay, this is raised to the third power, so it should cross the x-axis 3 or 1 times. Okay, so we have to kind of always keep in mind, is there a wiggle that could take place? And that is possible. So 18, we have x raised to the third minus 6x squared plus 11x minus 6. Okay, nice thing is this did truly cross at 2 very nice locations. Okay, so 1 comma 0 yields you to the binomial x minus 1. 2 comma 0 yields you to the binomial x minus 2. And 3 comma 0 yields you to having an answer of x minus 3. So that's truly what it comes out to. So let's go ahead and just use synthetic division on this. Okay, so we saw that 3 worked. And I'm just picking 3 because it's the bigger the numbers. I now have to know there's a 1 out front. I have x to the third, x to the second, x to the first. This is actually x to the 0, so you just put in your lead coefficients. Bring down your first number. 1 times 3 is 3. Combine these together. That gives me -3. Multiply outside, outside. That's going to give me -9. Combine those together. That gives me 2. 2 times 3 is 6. So you get the 0 right there. Again, that 0 right there means that the point 3 comma 0 is on our thing. Originally, it started out with x to the third. So what would this be right now if I put the letters back in? What did I say here? So notice 19 was x to the third. Down here, when I divided and got to 0, that became x to the second. So that means this
now becomes x squared minus 3x plus 2. And the nice thing is, if you got down to that point and you didn't have the technology available, if it was x squared minus 3x plus 2, you could try and factor it, or you could use the quadratic formula to go there. But we also found that it crossed at, I believe, 1. So let's try the 1 and synthetically divide it in here. First number comes straight down. 1 times 1 is 1. Combine those together, so that gives me -2. Multiply those, I get to -2, and I get a 0 down here. So again, the nice thing is that verifies that the point 1, 0 is on the graph. That allows us to know that, this one would have been x minus 3 as a binomial as the first answer. This would tell me that x minus 1 is another binomial. And then because I'm dividing it down, I can just take this last term right here, which is basically x minus 2, and there's my third binomial. So if I were to multiply x minus 3, x minus 2, and x minus 1 by all kinds of factoring or foiling and double distributing, it would work out. Okay, so this is a easy concept to watch sometimes when the teacher's doing it, and then all of a sudden you get home and it's like magic takes place, because it's like I forgot everything. A vanishing act of what I knew is gone. So this is not the most vital important thing. This is one of those things that you have the blessing of having Desmos, and you have the blessing of you get to work with each other. So as long as there's like one person in here who kind of feels good about it, that one person actually would be able to carry through other people on this type of problem, which is kind of cool. Okay, and it becomes a huge discussion thing, and it's, there's all kinds of reasons why the problem solving skill took place, but there's a movie, and I bet you might have seen it. Have you seen the movie called Apollo 13? You know the premise of the movie? Basically, Apollo 13 was supposed to go to the moon. Okay, it launched to go to the moon, and on its way, once it was out of Earth's orbit and was on its way to the moon, and it broken off the gravitational pull of the Earth, and it was now in the gravitational pull of the moon. This little capsule that was, there was 3 people inside of it, which was a very small 3-person place. They had a seal burst on one of their oxygen containers, which is bad because you're in outer space and there's no air out there. So they're like, okay, we can no longer go to the moon. We have to get back to Earth. Okay? Now, because how rockets work, so just kind of put it in a kind of a weird perspective. So if you have Earth here and you have moon here, okay, it basically, the rocket that they took, they were in this little tiny capsule on the top. There was 3 guys in here. Yay. So basically they were strapped to a rocket which had 3 stages. This first rocket would go, and this would basically get the rocket to about 60,000 feet. And then this would fall away, fall back to Earth. The second stage would take off and go, and this would get the rocket to about 140,000 feet above the Earth. Okay, 40,000 feet off the Earth. Then this would fall away, and then this one would take off, and this would basically allow them to break gravity, because Earth is saying, hey, come back to Earth. So this rocket, as it took off, basically did this. It went around a little bit bigger circle, and then that third stage hits, and it breaks. So technically, this is what this rocket's going to do, and it's going to use the gravitational pull of the moon to slow it down. But that little capsule where the guys are at, which basically looks like this, okay, and yes, this did connect to the lunar module, which is a whole different part of it, but the 3 guys are in this. This only had small little rockets on it, that are enough in outer space to slow it down to allow for certain things to take place. But once they were going this way at about 50,000 miles per hour, this did not have enough rocket thrust that if they could maneuver it around, and they had maneuvering thrusters that would allow it to pivot in 3 different dimensions, this didn't have enough rocket to stop it from being projected towards back to Earth. So they had to go to the moon. So basically what they had to do is they had to say, okay, we're no longer going to go to the moon. We're going to do this and hopefully get back to Earth. That was the whole thing. Well, what they did is they had a whole bunch of mathematicians that worked for NASA. And they basically went to the mathematicians, a large room of probably 50 to 100 mathematicians, and said, okay, this is our problem. We knew how to get to the moon. We didn't know how to get this to shoot past the moon, slingshot back around it, and come back to Earth. What's the math that's going to take place? They didn't leave that up to one person. Okay, this was some really complex math. This was math that wasn't synthetic division. This was basically, you have taken something and you've thrown it in outer space. How are you going to bring it back to Earth and everyone gets back alive? So they had to use all these mathematicians, and they had to work together in order to get the solution to get them back to Earth. So when you are working together with a huge problem, like our tests or quizzes, not huge, but that allows you to double check off of each other and build off each other, and you come up to a solution that you feel is comfortable as you would want on your test, which is great. Again, there's a lot of really good data to show that type of testing is a very beneficial type of testing. Yes, there is the one kid who hadn't shown up all year who shows up during the test. I don't really know how to take care of that situation other than if that person was working for a corporation. If they never showed up to work, they're probably not going to work there anymore, but we're not in the process of firing people as being students. But that's the whole idea of why, if you work together, you can come up with a common solution. Okay, let me pause my all right, algebra review number 2. This is definitely, make sure, let's have Desmos out because we're going to be utilizing it quite a bit. And I think you'll like this. Okay. This is really beautiful because Desmos is going to be our best friend here. Okay? These are not problems that we need to get it equal to 0. These are problems that we can graph the left side and we can graph the right side, and Desmos is going to tell us where they intersect. Okay? So it's as simple as this. Take a look at that very first problem. You have x squared minus 3x, and you have it's equal to 10. There's no reason to bring that 10 over. Again, I'm showing you different ways to think through these things. So I'm going to graph this. I'm going to have each side be its own equation. So I'm going to get x squared minus 3x, and then I'm going to go y equals 10. And then you kind of have to pinch down. Whoop. It helps when I actually type in 10 and not negative. So take a look at that graph. My friends, does the red and the blue intersect each other? Did you get that to work on your phone? Did you get that to work on Desmos? That's the first important thing. See if you can make that work. Can you make that work? Do you understand why I made that work that way? I basically took each side of my equation, and just know that if you're doing the squared, if you're doing it off the keypad, there are different functions down here, and this will show up on your phone. That'll help you get some of the functions in math, no problem. But let me know, can you get that? Can you squeeze, open and squeeze? I don't care that you don't have red and blue. I don't care if you have different colors. Just you have a parabola and a straight line intersecting each other. Show your friend or show your neighbor or show me. Got it? Getting it? Getting it? Cool. Getting it? Trying it? Getting it? Getting it? Is it working? Get it? Get it? Almost? Ooh, you're doing it on your tablet. I like this. Is it working okay on the tablet? Cool. You guys getting it okay? You should be here. Just get yours. And then you have to just kind of squeeze it down. Oh, you don't have 10 in yet. Well, then make sure you have 3x next to that. And then y equals, go down one line, y equals 10. There you go, that's it. Cool. So Desmos works. So friends, do you all agree that you have two different math equations that seem to cross each other? Does this make sense? So if you wanted to get your solution, your solutions are that. Now, quick question for you. In our original question, did we have y equals? Is there y any part of that original question? The answer is no. What letter do you have? There's x's. So where this crosses, you're going to look at just your x answer. So -2 and 5 are your solutions. So -2 and 5 are your solutions. You're looking, you want to solve for the letter that you're using, which is the x value. As far as the point goes, that will allow you to make that work very nicely. I'm going to see if I can move this thing up. That's kind of a fun way of looking at those problems, and I would bet you this type of way of looking at the problems takes you back to Algebra 1 or Algebra 2 going, dude, why didn't we learn this originally? Well, because those teachers haven't caught up with us yet. All right, so take a look at number 2. Try number 2 on your own. Set each side as its own problem. So now I'll type it up here, see if we can agree on how that works. And I got something that kind of looks like that. You let me know. And the nice thing about Desmos is it's touch screen, like your phone is, like a tablet is. It allows us to see something that's taking place. So I have a purple and I have a green line. In my case, you might not have purple and green, you might have other colors. So let me ask you this, my friends. How many places does it appear that the purple crosses the green? Looks like 3. Now, would that make sense? If it crosses 3 times, our original problem was raised to the 3rd power, agree? Which means we should have 3 solutions. And because we didn't have y as part of our answer, we're looking for just the x values. And the nice thing is, on Desmos, and it holds it, you just tap the 3 locations that you feel that it crosses. And so my answers, my x value answers, because I don't want the y values, I only want the x values, is you look at the x value of the point. So -2 is a solution, 0 is a solution, and 2 is a solution to the problem. Meaning if you had plugged those into the original problem, it's going to give you the same thing on the right side and the left side of the equal sign. Okay? I don't know, just it's a whole different way of thinking about math by allowing the technology to build us into what it's going for. So you could do the same thing for number 3. Hey, the problem with number 3, your second equation is y equals 275. So you're going to have to squeeze down in the y direction to find 275 where it crosses. Number 4 is done the same way. Number 5 is just one that you want to put it in slope-intercept form from standard form. So you just solve for y. Number 7 can be done the same way as well. Number 7 is also pretty easy to do because you just set each portion of it equal to 0 and solve it. But honestly, on number 7, if you were to plug in x parentheses or y equals x parentheses 5x minus 2 close parentheses open parentheses x plus 7 close parentheses, and then the second one is y equals 0, you're going to take a look where it crosses the x-axis because the x-axis is at 0. And you can solve that pretty easily. 8 done the same way. 9 done the same way. And And then you start getting down to number 11 and number 12. Number 11 and number 12, take a quick look down at those. Do number 11 and number 12 have both x and y as part of the answer? Does that feel comfortable to say that? So all you do for 11 and 12 is go ahead on Desmos, plug in y equals 26 minus 3x, and then your other equation right below it, y equals 4x minus 9. Tell me where they intersect. Give me the whole answer. The reason you're giving me the point is because there is an x and there is a y in this problem. Okay? So, let me just show you one more thing, then I'll call it good. Go down to 13, 14, 15. And let's take a look at number 13. They're all about equivalent type of problems. We're going to go right to Desmos for number 13. Get rid of this one. All right, so I'm going to go number 13. I have x minus 2, and I have x plus 3. Okay, it should be a parabola. Now, what does it say down below? Does it say equals 0? No, it says what? Greater than 0. Okay, so on Desmos, look at this. We have a greater than sign. Okay, we have that. Now, what I have to do is I want to do this. Actually, I'm going to change this back to an equal, and I'm going to say, where is y greater than 0? Okay, can anyone see that there is a different shaded region? Okay, that shaded region is going to tell us the interval we want to do, and they wanted us to use just greater than. That's why we have a dotted line. So our interval, where our parabola is greater than 0 above the x-axis, goes from, using the domain, from negative infinity, it's coming from this way, to this point right here, which appears to be 3. Okay? It's a dot. So your answer to that, so we have negative 3 and 2. So your answer to number 13, we have negative 2, and we had negative 3 and positive 2. Positive 2, we have negative 3. Okay, so using this, our interval is going to go from negative infinity to negative 3, soft bracket on the 3, because we don't have the equal sign underneath there, and then from 2 to infinity, and that's what our answer is. So I would ask you guys, why don't you try 1 through 15, see how you do. Don't spend any more than 4 minutes outside of this class working on this assignment. We can finish up more of it tomorrow. Deal? Everyone good?